Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains SR Linux routing policies in the data center underlay. Routing policies are used to manipulate the default operation of a routing protocol. They are configured independently of the routing protocols and can then be applied to OSPF, ISIS, and BGP. In data centers, external BGP or eBGP is becoming the protocol of choice for the underlay. The default behavior of eBGP is for the router to reject all routes received from peers and to not advertise any routes to peers. Routing policies are required to change this default behavior. Routing policies can be applied to the import or export of a protocol. A routing policy applied to the import of BGP affects the BGP ribbon, which contains updates received from BGP peers. An import policy is therefore used to control and manipulate the updates coming into the router. Updates accepted by the policy are presented to the router for further processing. A routing policy applied to the export of BGP affects the BGP ribout, which contains updates advertised to BGP peers. An export policy is therefore used to identify the routes to be advertised, such as allowing the advertisement of local routes or routes learned from another protocol. A routing policy is configured as a sequence of statements. Each statement can have one or more matching criteria and a defined action to take when an update matches. The action can be to accept, to reject, or to accept and manipulate some attributes associated to the update. The matching criteria can be IP prefix lists, AS path numbers, community values. If there is no matching statement in the policy, the default action of the policy or the protocol will be used for the updates. In our lab, BGP has been configured between the leaf and spine routers. The eBGP sessions are established. Leaf 2 is advertising its host 20 subnet. On Leaf 1, the default eBGP import policy has been modified to accept all routes received from the spine routers. We will now configure an export routing policy that allows Leaf 1 to advertise the subnet of its connected hosts 10, 11, and 12 to its eBGP peers. First, we'll verify that Leaf 1 is receiving routes from Spine 1 and Spine 2, and it is accepting them. We see that Leaf 1 is receiving updates from both spine routers. It is using 3 networks from Spine 1 and 2 networks from Spine 2. Also notice that Leaf 1 is not sending any route updates to Spine 1 or Spine 2. Now let's look at the route table for network instance default. We see that the 192.168.200 and 1.0/30 network that is being advertised from Leaf 2 is learned via the BGP session to Spine 1. We'll go to host 10 and try to ping host 20's IP address 192.168.200 and 1.2. The ping fails. This is because Leaf 2 does not have a route back to the 192.168.100 and 1.0/28 network, where host 10 resides. To allow the communication between hosts 10, 11, and 12 and host 20, we need to create a policy on Leaf 1 to advertise the 192.168.100 and 1.0/28 network to the spine routers. They, in turn, can forward that information to Leaf 2. First, we'll enter the candidate mode and then navigate to the routing policy context. We will create a prefix set called hosts. The prefix we'll define is 192.168.100 and 1.0/28, and we define the mask length range as exact to ensure that we only advertise this one prefix. Next, we'll create the policy. We'll call it export hosts. We'll define a statement using an ID of 10. We define the matching criteria as the prefix set hosts. We'll then configure the action that we want the protocol to take when there is a match. In this case, we want to accept the prefix. Next, we'll define the default action of the policy. This will be the action it takes if there is no match. In this case, we'll set the default action to reject. We'll use the info command to validate our policy, and if we are satisfied, we can then exit the routing policy context and navigate to protocol BGP. Once in BGP, we can apply the configured policy in various contexts. We can apply it at the global level of BGP, the group level, or under a specific neighbor. In our case, we want to send the updates to both spine routers, so we will apply the policy to the group spine. We go to group spine, then enter export policy and add the policy name, in this case export hosts. We use commit stay to commit the change and stay in the BGP context. We look at our BGP neighbors and see that Leaf1 is now sending an update to both spine routers. We check the update being sent to spine 1 and see that it is the network prefix 192.168.100 and 1.0/28. We go back to host 10 and try to ping host 20's IP address 192.168.201.2 again. This time the ping is successful as Leaf2 now has a route back to the host 10's network. That's it for SR Linux routing policies. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.